Me again. Okay, let me present my screen and let's just go over what you just did. We'll start with the scatter plot, men's, what was it, 100-meter run. Now, trend lines are usually used to make predictions, and on this one, it's going to feel like we're predicting the past, which is true. However, it helps kind of in this case because I can show you what happened and see just about how accurate we are. All right, so this was the one you did. The first thing you should have done was to plot the points. Yes, there were a lot of them. Just notice again that they're not putting in like the 1930, the 1940. Makes it a lot easier, especially when you're going to do some work with the calculator. Okay, so you had to plot the points, and your scatter plot basically should have looked like that. We have a negative correlation here. And it's not super tight, so don't be surprised if your trend line is a bit off. Okay, next thing you're going to do is draw that trend line through the center, and that's where I saw mine going. And yes, I do not have the arrows on there. I apologize. Okay, moving on, so we're going to get the equation of the trend line. So I want 2 points on my trend line. I'm going to go down looking for 2 in the crosshairs. I see one there. And if I come down, that's a close one. I go all the way down looking for them. And you can see that I ring them. I pick that one and I pick this one. And here are the coordinates. Once I have the coordinates, I'm going to calculate the slope. My slope comes out to be about a negative 0.032. I then use one of my points with that slope. I'm not going to use my y-intercept because, again, there is a break in the graph down here, so it wouldn't be accurate. So I'm going to take y minus the y coordinate equals my slope times x minus the x coordinate, distributive property, add the 9.8, and here is my slope intercept. You should be close-ish. Okay, you should have a negative slope. I mean, look at this. This is less than negative 0.05. And your y-intercept, shouldn't be 422, okay? So basically, if we now use this, we can make a, quote, prediction, but of course this has already happened, to see what would have happened in 2016. And we're going to put that in, and then I Googled it to see what really happened. So to put the number in for X, which would be our years after 1900, so 2000 would be 100 years. This would be 116. So you're going to let X equal 116. And I would get 9.45 seconds. And when I looked it up, Usain Bolt actually won in 2016, and he ran the race at 9.81 seconds. So we expected, or at least I did on my line, expected him to go a little bit faster than that. So, is the trend that this line is expecting sort of folks to go too fast? At some point, it has to level off. You can't run the 100-meter run in 4 seconds or something like that. So that could be starting to happen. Okay, the next thing I want to do is look at the too hot reporting template. Usually we do this, it's 2 people, higher order thinking. We usually do it in pairs, not happening this year. So let me get that answer key up. And we'll take a look again. Sorry about the shadows, but this is where I'm at right now. So a missile's fired at 1320 military time. That would be 1:20 in the afternoon. It reaches the ship 20 miles away at 1330. Calculate the missile's rate of change. So in this particular case, you're going to have that distance depend on time, distance on time. So this is, at 1320, the missile hadn't gone anywhere. That's why there's a 0. Let me just see if I can get that a little bit sharper. Sorry. And then basically 10 minutes later, it is 20 miles away. Y minus Y, X minus X, and it's going 2 miles per minute would be the rate of change. So there's just an example of calculating slope, again, just a review. And also, rate of change is basically slope with units. And it's a unit rate, so we wouldn't leave it as a rate of change. We make it a unit rate by dividing. The next one's pretty interesting. This is having to do with blood pressure. And we're going to talk about 210. And I think that's mercury, by the way. So blood pressure's unit. And 210 systolic blood pressure 10 minutes after taking a nitroglycerin, which is supposed to bring your blood pressure down. So if somebody is actually starting to have a heart attack, or they're concerned that they might have one, they carry around a medicine called nitroglycerin. And if they start to feel it coming on, it helps bring down the blood pressure. So this is, very high blood pressure. And 10 minutes after, it's dropped to 100. Now, the blood pressure is going to depend on time, how much time has gone by in this case. So I have 2 points. This is kind of a case 3 example, and I'm going to calculate my slope, and it's dropping 11 millimeters of mercury over 1 minute. That's my unit rate. And now the second question asked to model it with a slope intercept. Really easy to do because I was given the y-intercept. So I didn't even have to do point slope. Y equals negative 11x plus 210. And notice I'm defining my variables. And what would the blood pressure be after 20 minutes? And if you calculate that, sorry, I got all kinds of things in the way here. If you calculate that, you're going to end up with negative 10. Big question mark. That basically means you died. I mean, you more than died. Blood pressure can't be negative. So again, in theory, this would be the answer. In practice, it can't happen. So sometimes you've got to watch what you're doing in math, that, your answers make sense. So this would only go so far. And then you would either be dead, no offense, or you would, the model obviously changes. Okay, the last one would be these are just the questions. These should be relatively easy for you because your algebra. These are the Math 8 questions that would be on an IEB interim assessment block, or, that SBAC, it's now called the SBA test, would be in May. So this one should have been really easy. You find 2 points, they plotted them. Your y-intercept is 1, and it's going down 2 over 3. To be perfectly honest, they don't have the most likely wrong answer would be to forget the positive. So y equals mx plus b. The next one, Jeremy is shown the graph. What did he do? He did a very common mistake here where he put the run over the rise. So the slope should be 2, not 1/2. You're going up 2 and over 1. Y-intercept is 1. So the answer would be A. The slope of the graph is 2, and the equation should be that. All right, on the back. So Latricia claims that this is a function, but not a linear function. What statement supports her claim? The graph of the function would not be a straight line. You guys are, more, no offense, but smarter than your Math 8 counterparts, because we've already done that function unit, and you actually already know what this looks like. And you know that it's a parabola opening up, 3 units shifted up. I mean, we did all that in Unit 3, and we'll do more of it in Unit 8. So the reason that it's not linear, it won't form a straight line. Next 9, select all pairs. I want to put this on here to make sure you're always looking for that word all. And if you did this, you're basically just plugging in your X and your Y and doing it like a check to see if it works. So I just did 2 of them out, but the first one, if you do the math and put the -3 times 2/3 and add 1, it would be -2 plus 1 is -1. So that works. The next one, if you put the -2 in, you get -4/3 plus 1, which is -1/3, and that doesn't work. The next one is a check. It's kind of very faint. That is good. And the last one is a no. Okay, the last one here is kind of interesting reading this graph. Notice it has kind of a bend in it. So you have to decide, is it less than 10, equal to 10, or greater than 10? So the number of the panels can get from $100. So, if you come up to $100 and kind of hit here and see how many panels you can get, it's going to be less than 10. So come over and hit your line, and you can see it's less than 10. The cost in dollars to get a single panel is really hard to see here, but remember that the slope of this line is going to be constant. So if you look at this point and take the 60 divided by 4, the slope of this line is 15. So the cost would be more than 10. It's $15. The next one is what we just did. The average cost for 4 panels is there's 60, and 60 divided by 4 is 15. And the average cost per panel in dollars when the customer orders 12, you'd come up to 12, hit, and kind of go over, and you can see that it would be greater than the 10 because that 140, divided by 12. So that should take care of that. Excuse me, I'm losing my voice. And that takes care of listening to me today. Sorry again that everything's coming to you through video, but it's all I got right now. So I hope everything's going well, guys. Have a nice afternoon, and you'll see me again soon. Take care, everybody.